All right, everybody, we are into our final unit for this course. We're going to start with Lesson 1, Antiderivatives and the Indefinite Integral. So you might have some idea what an antiderivative is just based on the name, but, we'll see. So, example 1, write a function, big f of x, that has its derivative, little f of x, is equal to 2x. In other words, what's a function that if we take the derivative, we'll get 2x? So I would say that a simple choice here would just be x squared, right? Because we can check that. Because we can say that little f of x would then be equal to f prime of x, which is d dx of x squared, which is 2x, right? Just by doing our basic power rule. So this, go figure, is the antiderivative. So in general, the antiderivative of f of x is big F when big F prime is equal to f of x. It's just the reverse of taking the derivative. If you recall, to take the derivative of a power rule, we have f of x is equal to x to the power of n, then f prime of x is equal to n times x to the n minus 1. We bring down the exponent out in the front as a coefficient, and then we subtract 1 from the exponent. So it makes sense that the antiderivative is going to go in reverse. We're going to add 1 to the exponent and then divide by that new exponent. And we can actually see that in our example up here. So if you think about it, if we have that f of x is equal to 2x, then we can see that big F of x is equal to 2x. Now normally x just has a power of 1, so we're going to add 1 to that, and then divide by 1 plus 1, which is 2x squared over 2, or just x squared. Cha-ching. So you can see how that process works. But is that x squared the only possible big F of x, the only possible antiderivative of 2x? Well, no. There's actually quite a number of them. It could be a lot of different kinds of functions. There are many possible functions. And by many, I mean infinitely many. In fact, let's be clear about that. There are, in fact, infinitely many possible functions. I can spell infinitely, maybe. For example, what about x squared plus 2? Or x squared minus 16, or x squared plus 1,000,000,003, right? All constants, when we take their derivative, are just 0. So we can add any constant, and it will still have the same antiderivative. That's why we can actually say the most general antiderivative of little f of x is f of x, big F of x, is equal to, in this case, x squared plus c, where c is some constant. And in fact, this applies to all antiderivatives. The antiderivative, the most general antiderivative, is always going to be the big F of x plus c, where c is some constant, right? So we have that the integral of little f of x dx is equal to f of x plus c, big F of x plus c. Now, just being aware of this notation, this symbol means integral. That's just another word for antiderivative, basically. And note that we have dx at the end. That's the same way that we use ddx to denote that we're taking the derivative. We use the integral sign and dx at the end to indicate that we are taking the integral with respect to x. So we know which variable we're taking our integral with respect to. All right.
Hello there, this is Italics coming in from the future, just checking in because I feel like my human did a pretty terrible job explaining the difference between an antiderivative and an indefinite integral. so allow me to explain. The antiderivative of f of x is any function, so that if you take the derivative, you get back to f of x. No constant added required. However, the most general antiderivative, or indefinite integral, is the set of all possible antiderivatives, and therefore a constant is a must. Just wanted to make sure that was clear. Now back to my silly, silly human.
Let's give some of these a try. So, these are a bunch of different kinds of antiderivatives. This one might take a hot minute, but go through and see if you can fill in a bunch of this table without me, right? Pause the video, do it yourself, and then skim through the video and see if you get all the same answers as I do. Give it a shot. But either way, I'm going to go ahead with this. So I'm going to be taking the antiderivative of -8 with respect to x. And again, we know that we can also write -8 as -8x to the power of 0, right? Because x to the power of 0 is just 1. So what this means is that I'm going to find that the antiderivative is going to be -8x to the 0 plus 1 all over 0 plus 1, which is just -8x. All right, now we can check our work. d dx of -8x. Oh, hey, what did I forget? There's something very important that I didn't write down, isn't there? Plus c. This is a really common mistake. I just made it. You're probably going to make it more than once. Don't forget to add your plus c. It's really important when we're taking the antiderivative. We acknowledge that there is a potential constant there. That constant could be 0, but it could be literally infinitely anything else. So I'm going to take the derivative of -8x plus c, important, and I find, hey, the derivative of -8x is just -8. The derivative of any constant is just 0, so that gives me -8. Perfect. Okay, next one. So I'm taking the integral of x cubed. Notice that I'm using a bracket to indicate that I'm taking the integral of all of this. Just saying. Plus 5x minus 7 dx. Taking the integral with respect to x. So what I do, here we go. This is going to be x to the 3 plus 1 divided by 3 plus 1 minus 4x to the 2 plus 1 divided by 2 plus 1 plus 5x to the power of 1 plus 1 divided by 1 plus 1 plus 7x. I know it's technically 7x to the 0 plus 1 over 0 plus 1. I don't want to do it. You get it. I hope you get it. Plus c. All right. What this gives me is this is going to be 1/4 x to the 4 minus 4/3 x cubed plus 5/2 x squared plus 7x plus c. Okay, now we check our work. We find d dx. We work backwards. And this is the great thing about this. If you're ever not sure if you did the integral right, just take the derivative and see if you get back to the beginning. So we're going to have the derivative of 1/4 x to the 4 minus 4/3 x cubed plus 5/2 x squared minus 7x plus c. That's going to give us, we're going to bring down that 4, so it's going to be 1/4 4 x cubed minus 4/3 3 x squared plus 5/2 times 2 x to the power of 1 minus 7 plus 0, or x cubed minus 4x squared plus 5x minus 7. Cha-ching! All right, let's try something a little more challenging. So I've got this y is equal to 4 over x. So I'm asking for the integral of 4 over x dx. I'm going to rewrite this a little bit. This is equal to the integral of 4 times 1 over x dx. Now, here's something we need to take note of. If we try and use our little power idea, you might be really tempted to just rewrite 1 over x as x to the -1, which, I mean, of course you can, but then you might be tempted to say, oh, well, then I can find the derivative by going the integral of x to the -1 dx is equal to x to the -1 plus 1 all over -1 plus 1. But you might notice a problem there. That gives us x to the 0 over 0. Can't divide by 0. So, But here's the thing. You might also be tempted to say, well, then that means that this thing isn't solvable. It's done. But if you stretch back to our previous unit, you might recall that we actually do know something that has a derivative of 1 over x. And it's the natural log. So for this one, we're not going to use our power rule. We're going to instead just have this be 4 times the natural log of the absolute value of x, because either way it's going to come out to 1 over x dx. I don't know why I wrote dx. I meant plus c. There we go. That's what I meant to write. So if we check our work here, we find that we're looking for d dx of 4 natural log of x plus c. And we know, based on our derivatives for natural logs, that's 4 times 1 over x plus 0, which is just 4 over x. So be careful. Don't try and use the power rule thing when you're dealing with 1 over x. It won't work. It'll work for other negative exponents, just not x to the -1. Okay, because that's the one where we're going to get division by 0. All right, e to the 3x. So remember, e to the 3x, or any kind of exponential function where it's e to the power of x, we just have to deal with the chain rule part, right? So in this case, if I want to deal with the integral of e to the 3x dx, I have to consider the fact that when I take my antiderivative, yeah, this guy's not going to change, because when we take the derivative of e to the 3x, it's still e to the 3x, but we have to multiply by the derivative of the interior function, by the derivative of 3x. So when we take the antiderivative, we have to account for that. So we multiply by the reciprocal of that coefficient. That way, when we take the derivative, they'll cancel out. Allow me to demonstrate. d dx. Oh, I almost forgot. Plus c. d dx of 1/3 e to the 3x plus c. That's just equal to 1/3 times, e to the 3x, but we also have to multiply by the interior of that, which is 3 by the derivative of the interior function, and the derivative of c is 0. So what we get left with is e to the 3x. Boom. All right, last two. Sine of 4x. So we've got sine of 4x dx. And if you think about this one, remember that the derivative of cosine is negative sine, right? So the antiderivative of positive sine should be negative cosine. That way the negatives will cancel out when we take the derivative. But I also know that when I take this derivative, I'm going to get a 4 on the outside from chain rule. So I have to multiply by 1 over 4 to counteract that, plus add my constant. So this is going to be negative 1/4 cosine 4x plus c. So what that gives me over here then, d dx, if I check, negative 1/4 cosine of 4x plus c. By derivatives, I get that I have my negative 1/4 out here. The derivative of cos 4x, well, derivative of cos is negative sine. And we have to multiply by the interior function there, which is going to give me a 4. And then I add my c. And the 4's cancel out, the negatives cancel out, and I'm left with sine of 4x. And, oh, that's a 0, not a c. We took the derivative, it's gone. Negative sine of 4x, and we're done. Really similar with cos of 7x. Integral of cos 7x dx is just going to be the same idea, 1 over 7 sine of 7x plus c. For the exact same reason as the previous one, derivative of sine of 7x is cos. We can see that over here, d dx of 1 over 7 sine of 7x plus c. is just going to be equal to 1 over 7 times 7 sine, not sine, derivative of sine is cosine, there we go, plus 0, or just cosine 7x. All right, so you can actually see a summary of all of these general antiderivatives right here. So this chart will be really helpful if you're having a hard time keeping track, but all of these are useful, but at the end of the day, you can get a lot of these just by working backwards, by knowing your derivatives very well. All right, let's actually use some of these, shall we? So, we're going to start with our try 1a. F of x is equal to 4x to the 7. Okay, I'm going to do this one pretty quickly. So I'm looking for the derivative of 4x to the power of 7 dx. The antiderivative, I should say. So what I get is this is going to be 4x to the 7 plus 1 all over 7 plus 1 plus my constant c, which is equal to 4x to the power of 8 all over 8 plus c, or let's just make this a little bit nicer, x to the power of 8 over 2 plus c. Okay. Or 1/2 x to the power of 8 over c plus c, that works too. Either one's fine. All right, c, for some reason. I don't know the alphabet, guys. I'm a math teacher. Give me a break. All right, so here, our big F of x is going to be equal to the integral of 4x cubed minus 6x squared plus 11 dx. So our antiderivative, or indefinite integral, will be 4x to the 3 plus 1 all over 3 plus 1 minus 6x to the 2 plus 1 all over 2 plus 1 plus 11x to the 0 plus 1 all over 0 plus 1 plus c. Again, you'll get really, really used to doing this in your head as we move forward, and you probably will be able to skip a lot of these steps in the future. But for now, I will include them. There we go. Polynomials are pretty simple, because you just have to keep applying that reverse power rule. D, I guess, that should be C. I don't know. I'm just gonna roll with it. So we have that f of x, our big F of x, is going to be the integral of, I'm going to rewrite this as 7 times x to the negative 3. So remember I said we can't use our reverse power rule on x to the negative 1, but we can totally use it on x to the negative 3. It's not going to be 0, so we're good to go. So what we get is this is 7x to the negative 3 plus 1 all over negative 3 plus 1 plus c, which is just negative 7 over 2x squared plus c. And not e. So we have f of x is equal to little f of x. That's not what I wanted to write at all. Big F of x. And now I can't erase. Now my tablet is, there we go. I got there in the end. And that's really what matters, isn't it? Now I'm going to just change this into its rational form, this rational exponent form, just because it's a little bit easier to work with. Because then I can use my power rule, right? So this might have fractional exponents, but that changes absolutely nothing. It's still just going to add 1, but because I want to make my life easy, I'm going to write it as 3 over 3. That way I have a common denominator already. And divided by 2 over 3 plus 3 over 3, which gives me x to the 5/3 all over 5/3 plus c. But that's super gross. I don't like it. Let's go with 3/5 x to the 5/3 plus c. Or, if you want to put it back in the radical form, you totally can. That would be 3/5 cubed root of x to the 5 plus c, but I don't really like this because we can totally break up x to the power 5 when we're taking a cube root. So if you're going to turn it to radical form, you might as well go all the way and rewrite this as 3x over 5 cube root of x squared plus c. Either one of these is totally fine. Either of these boxed ones is good with me. Okie dokie. Example 3. Let's do some not just power rule-y stuff here. So we're looking for the antiderivative, the indefinite integral of 2 cos x plus 3 dx. So to do that, we're just going to work in reverse. The 2 just gets left out there. We know the antiderivative of cosine of x is going to be negative sine of x. Is just cosine of x. 3, 2, 1. We know the antiderivative of cosine of x is just sine x. And the antiderivative of 3 is just 3x. Again, we don't have to worry about the coefficient on the sine x there because it's just going to be 1, so we can ignore that. And then we add c. Oops, that's not supposed to be a bracket. There we go. And what we're left with is 2 sine x plus 3x plus c is our answer. Okay, let's try this puppy. So we are looking for our big F of x. That's going to be equal to the integral of 4 times 1 over x plus e to the x dx. So 4, we just leave it out, it's coefficient. The antiderivative of 1 over x is the natural log of the absolute value of x. Plus, well, the antiderivative of e to the x is just e to the x, because the derivative of e to the x is just e to the x. So that one's nice and simple, plus c. All right, then we're here. Big F of x is equal to the antiderivative of negative 3e to the negative x plus 3e to the 2x dx, which, okay, so when I walk through this, I'm gonna pull out that coefficient. Then, okay, I do have a coefficient on my exponent here, my exponent of x, so I'm going to divide by that exponent, divide by the negative 1, e to the negative x, plus, and then I do the same thing here, 3 times 1/2 e to the 2x, just like what's in that table, plus c. And what I'm left with is positive 3e to the negative x plus 3/2 e to the 2x plus c. All right, last one. We're almost done. So with this one, we have big F of x is equal to the integral of, and okay, I'm going to rewrite these ones all as powers, 2x to the negative 2 plus, this one I'm going to write a little differently. I'm going to write it as 5 times 1 over x. I'm just going to do that so you don't try and use power rule. Remember, for this one, we have to use that natural logarithm. Plus, and in this case, just x dx. If it helps, you totally can write this as x to the power of 1 if you want. Which makes this equal to, okay, so it's going to be, the way that I'm going to do this is I'm going to do this as 2x to the negative 2 plus 1 all over negative 2 plus 1 plus, again, this is just going to be 5 natural log of absolute value of x plus x to the power of 1 plus 1 all over 2 plus c. And what this simplifies to is negative 2 over x plus 5 natural log of absolute value of x plus 1/2 x squared plus c. And that, my friends, is antiderivatives and indefinite integrals. Get some homework done, really practice this. You really want to have this well and down because we're going to be using this for the rest of the unit. Okay, peace.